Today's show is brought to you by ExpressVPN. Protect your online activity today and find out how you can get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Visit tryexpressvpn.com/space to learn more.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello and thank you for joining us on this episode of the podcast we affectionately call Space Nuts. My name is Andrew Dunkley and with me is astronomer at large Professor Fred Watson.
Thank you, Andrew. Thank you for using my correct title. It's very gratifying to hear that.
Well, I don't like being criticised. That's what it comes down to. I don't like negative emails.
Quite so, yeah. And look, to be honest, I'm definitely not hung up on being Professor Watson. Fred is perfectly acceptable.
Thank you for saying that, Fred. I appreciate it. Now, we've got a bit to talk about today. Hayabusa 2 has landed on a chunk of rock, and spectacularly so, and everybody in Japan is really happy. That is until they found out it was the wrong rock. No, kidding. Virgin Galactic's done another test flight and very successfully. It's actually quite spectacular, the video that they took. But it's also another amazing first in space travel, which we will talk about. And we've got a question from David Putzia from Oregon. Say hello to Homer, because he lives in Springfield. About how is it that our galaxy is going to crash into the Andromeda galaxy when the universe is expanding? Shouldn't they be actually tearing themselves apart and vanishing off into the, wherever? So we will answer that, David, because that is a blasted good question, I might add. But first, Fred, Japan's Hayabusa 2 spacecraft has... I was going to say splashed down, but you don't splash down on an asteroid, and it didn't crash down either, so it was something in between.
The official term is touched down.
Oh, of course.
Yeah.
Why didn't I think of that?
Yeah, touchdown. So it did a touchdown, and it's going to do some more as well. So Hayabusa 2, which is currently in orbit around an asteroid called Ryugu, Ryugu. I'm probably not pronouncing it properly, but it's never mind. That's the name of the asteroid. It's not a big asteroid. It's less than 1 kilometre across. It's got a very interesting shape, actually. It's kind of diamond shaped. And that diamond shape is almost whatever direction you look at it from, it's diamond shaped. And that's, really interesting given these sorts of issues on the way things look, what we in the trade call morphology, which we were talking about last week.
Yes, because of the gingerbread man.
Yeah, the gingerbread man, Ultima Thule, that's right. So this one, I think it looks like a child's spinning top, actually. I remember.
Oh, yeah.
When I was a kid. But it's, 900 meters in diameter and of great interest because, like all asteroids, it's probably the building blocks of the solar system that you're seeing there. And we know from previous work that there's some really interesting compounds on the surfaces of asteroids, what we call organic compounds, things with carbon in them. And so, that's all led some people to suspect that perhaps that life came from space, came from an asteroid, the raw materials of life. Anyway, to cut to the chase, this little spacecraft, which currently is orbiting about 20 kilometers from Ryugu, has done a number of things. But it last year, I think it would have been about October last year, it dropped 2 little rovers on the side.
Oh, yeah, that's right. Yeah, we talked about that.
Yeah.
This has been quite an extraordinary mission.
It has, yeah. And it's not over yet. So they have also now touched down the spacecraft on the asteroid. And this, we always think of a landing on something as being a bit like when Elon Musk sends back his booster rockets and you've got things with flames coming out to stop the gravitational pull and break it and touch down gently on a surface. Well, it's a bit like that, but less spectacular on a 900-meter across asteroid, because the gravity is next to nothing. And so the biggest problem with touching down is avoiding bouncing off again, which is, of course, is what happened with that little Philae lander on comet Churyumov-Gerasimenko that we covered a couple of years ago.
Yeah, it got a bit bouncy, that one.
Got bouncy, that's right. So, but this one seems to have worked. And what they've done, they've sort of landed the spacecraft on the surface of the asteroid. It's been delayed, the action of doing that. I think it was supposed to happen last October, but they had problems finding a smooth enough bit of the asteroid to land on. It's covered in rocks and boulders, and the last thing you want to do is land on a tilt, because you might not get off again. But what they've got on the underneath of the spacecraft, if I can use that term, the underneath in relation to the asteroid itself, there is a thing called the dust horn. And it is a horn-shaped tube, I guess. I was going to call it a vessel, but it's not a vessel because it's open at one end, which lands on the spacecraft, on the asteroid surface. So this horn touches the surface, and then, this is the really clever bit, they shoot a bullet into it through the horn. So it lands on the surface and raises a cloud of dust, which is captured by the dust horn, or to give it its technical name, it's a sampler horn, because it takes a sample of the dust of the asteroid. So that, I believe, happened last week, maybe even the beginning of this week, actually. It's certainly the week beginning the 25th of February. So that little bullet, it's no mean thing. This thing weighs 5 grams, which is about bullet
size.
Bullet mass, yeah. It's made of the metal tantalum. I'm not sure why that is, but I'm sure if I checked out tantalum's atomic weight or something, I'd know the answer. I think it's quite dense. And it was fired into the surface of the asteroid at 1/3 of a kilometre per second. So that's pretty good going.
That's pretty
and so
fast.
The particles hopefully have been caught by that sampler horn, and then the spacecraft retreated back to its sort of safe position in orbit 20 kilometres from the asteroid surface. What we have seen in terms of images from the asteroid itself is a discoloured area around where this sample was taken from, and it's not quite clear whether that discolouring is from the exhaust of the rockets when it left the surface to go back up to its 20 kilometre station, or whether it's sort of splatter from the bullet itself.
Okay. Either way, we made that mark.
Exactly, that's right. Either way, we made the mark. So very interesting stuff. And the spacecraft is going to remain in orbit around Ryugu for another, I think it's the best part of a year, maybe not quite that long. But it will bring the sample back in 2020, back to Earth. That's when we'll get to see what it's collected in its sampler horn this week.
Okay, fabulous. And by the way, the atomic weight of tantalum is 180.94788 U.
Okay, good, thanks.
Just thought you'd like to know.
I do, yeah.
I had to think hard to remember that.
I bet you did, yes. It's a number I don't really carry around in my head, but I'm very glad to see that you do, Andrew.
And its atomic number is 73.
Yes, okay, so it's quite a long way down the periodic table.
Indeed.
Which, by the way, we're celebrating its
sesquicentenary.
That's right, yes, later, in fact, next month in March.
Yes. Okay, so now I suppose the sideline story to this is that the Japanese are really doing some pretty amazing stuff. We've seen quite a few relatively new entities into the space race doing things like landing on the moon, which the Chinese have just done, and releasing a rover, and now this, and India's in the game. I mean, it's just getting so exciting, really, isn't it?
I absolutely agree. It's we live in really interesting times, Andrew, and I just feel privileged to be watching all this sort of stuff going on, and in particular, for us to be learning things about, well, the far side of the moon, and about a little asteroid after a 300 million kilometer journey by a plucky little spacecraft. You know, they did this before in the mid 2000s with Hayabusa 1,
Yes.
and an asteroid. Which, if I remember, was called Itokaya. I think that was its name. And they did take a sample from it. Itokawa, that was it. Sorry, I got it wrong. Itokawa was the name of the asteroid that Hayabusa 1 landed on in 2005 and brought back some dust from that. And that was a really epic story. It got sort of sidelined somehow and nearly went into orbit around Venus, going completely the wrong direction. But they eventually got back and made it all succeed. It was great stuff. It's worth it.
And I suppose the question that sort of manifested itself in my mind when you said that they think that asteroids could be the way life seeded on Earth with an asteroid impact or something. If these asteroids all sort of like, we're collecting samples from a few now and getting information from them, if they all start to look like they're a bit samey, then it stands to reason that that's the pattern throughout the universe, and maybe other planets have been seeded.
Yeah, that's absolutely right. Your logic is impeccable as always, Andrew.
Yeah, well, that's a change. But so we have to wait till 2020 to get the dirt back.
Let's see what's in it. Yeah, I mean, it could be all kinds of things in it. And of course, asteroids are a bit of a hot topic because people believe that they might be rich in rare metals and things of that sort, which might make them worth mining. There are at least 2 companies that have been set up to do that.
Yep. The universe is our oyster, by the sound of it.
You might even find oysters, who knows?
You might, or pearls for that matter. All right, I'm sure there'll be more to hear from Hayabusa 2 in the not too distant future. You're listening to Space Nuts. Andrew Dunkley here with Fred Watson, Professor. Now, let's take a little break and find out more about our sponsor, ExpressVPN, rated #1 by TechRadar. This is the one I use. I've been using it for a couple of years and I love it. When I joined ExpressVPN, they were brand new to the market, but I read a lot of reviews and did a lot of comparisons. And there was just something about their business model that I particularly liked. And a couple of years down the track, honestly, can't complain. Their interface is very easy to use. Their service is second to none. I've had to contact them a couple of times about certain things that I wanted to do, and they were brilliant. So you may be wondering why I do need a VPN at all. It's all about privacy. Do you really want big tech companies, governments and others knowing what's going on with your online activity? Even if you're having nothing to hide, it just feels downright creepy. I think you'll agree. And governments are getting more and more interested in what you're doing every day. And so, protecting your privacy is what VPN is all about. And how often do you run across websites that you want to get information from only to find that they're geo-blocked? This is becoming an increasing problem, but ExpressVPN solves that problem for you. Now, if you go to our special URL, you'll see quite a list of things this service can help you with, things you may never have thought of before. As I say, it's the one I use, secure, fast, and it just works. So protect yourself online today and find out more about how to get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Try expressvpn.com/space to learn more, and you'll find the link details in the show notes and on our website. Now, back to the show.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
Now, Fred, we turn our attention to space tourism, and Virgin Galactic has just done a flight which has been historic for more than one reason. Obviously, it was a success, and very spectacular images on the BBC News website if you want to look it up. But something else extraordinary happened here, and it involved one of the astronauts.
Indeed, that's right. Let me read what he said when he came back down and landed back in the Mojave Desert.
Well, if you're going to quote him, better do the accent.
That's what I was going to say. It was thrilling yet smooth and nicely controlled throughout, with a view at the top of the Earth from space, which exceeded all our expectations. I'm sorry, Dave. Dave Mackay. Really sorry. Probably
That was really good. Really good.
Yeah, look, as an honorary Scotsman, I can get away with that usually.
And he is the first ever Scottish astronaut.
He is, that's right.
As a consequence.
He's from well up in the north of Scotland, from Helmsdale, which is way up in the Highlands.
Well, I mean, that's not an achievement because he's close enough to walk.
That's right. That's right. So he's the first Scottish-born pilot to travel to space. And by space, what Virgin means is, I think they mean above 80 kilometres. But this time they've gone beyond that. Dave Mackay took the rocket plane up to 90 kilometres. It looks as though it has been an absolutely perfectly successful trip, and that the footage that we've seen, as you mentioned, there's some nice footage on the BBC News website. It shows these elated pilots taking the spacecraft up. I think what happens, Andrew, is the rocket motor. So it's dropped from its mothership at about 15 kilometres above the Earth, which is 40,000 feet-ish or something like that. I can't do the calculation. I'm sure you will in a minute. And it's dropped from that height, and then they fire the rocket motor, which I think burns for about 30 or 40 seconds, something like that, accelerating the spacecraft up to a speed that basically, once the rocket motor cuts out, it coasts the rest of the way up to the what's called the apogee, the point furthest away from the centre of the Earth, where the spacecraft turns around and starts coming back again. And so for all that time, when the rocket motor's not firing, until the air brakes start on its way back down, for all that time you're weightless. And it's about 4 minutes, I think, the total time. So a great experience. And, you know, seeing things like this, what's I guess, surprised me a bit, or maybe encouraged me a bit, Andrew, is the fact that this the report that we've seen on this is pretty low key, which is almost Virgin's way of saying, look, guys, this is getting pretty routine. We don't need to make a big splash about it because we're going to be doing this every day soon. So I think it's rather an interesting, an interesting dynamic in the report. Some good footage, which you and I commented on a few minutes ago.
Yes, indeed. And one of the most spectacular spaceships I think I've ever seen. It's straight out of a science fiction story, that thing. The craft is just beautifully winged. It's got a single fuselage with a very pointy nose, and it's got the portals, it's got the rocket engine, it's got the fins and the wings. I mean, it looks like an attack craft from an alien race. I mean, it looks amazing. It's spectacular.
It does. It's definitely a spaceship, isn't it?
Oh, yeah. There's no denying it. I mean, that's what a spaceship should look like.
Yeah, it looks a bit different when it's coming down because it folds in half. The wing basically it's what's called a canting wing. So it actually has a hinge all the way along it, and the back half of it folds up almost at a right angle with the line of the wing to act as an air brake. And that clearly works very well.
Yes, indeed. So where does this put Virgin Galactic in the race to put tourists in space? I mean, we've got a couple of entities working on this. This one sounds like it's put them in a pretty good position.
I think that's right. The great thing about Virgin Galactic is they've been completely upfront with all their pluses and minuses. They have taken us the whole way, even though for many years we've been hearing that the first commercial flights will be next year. I do think they have handled this with great care and done all they can to ensure the safety of their passengers and to make sure that what they're talking about is actually going to work, and it's it is a good, reliable product.
So was this basically a test run of what the tourists will actually
pretty well
experience?
Yeah, that's right.
Okay.
I mean, basically, you go up and then you come down again. But for their $200,000, which was the initial price for these, you get a bit more than that because I think you get a week of training and instruction and just finding out all there is to know about space tourism, and you probably get a few good meals and a couple of nice glasses of wine, I would imagine.
Yeah, you have to eat it all out of a tube, but it's still fun.
That's on the ground, not in the sky. Yeah, good stuff.
Yeah, and one interesting thing that you noticed in the footage on the BBC News website was there were two pilots, including Dave Mackay, the Scottish astronaut, and they were all in their gear. I mean, they had the pressure suits on and their helmets, and they were all wired up, and they had the breathing apparatus. And then there was a guy in the back seat with a pair of sunglasses on, and he had no protective gear whatsoever. And I thought you were seeing things, so I watched again, and sure enough, this head pokes up with a pair of sunnies on. And I gleaned from the situation because there was one piece of footage showing from behind the pilots, and I thought, he's a cameraman. So they didn't actually have a fixed camera. They had a bloke with a camera, I think, and that's who the cameraman was.
You sure it wasn't a camera girl?
No, it was definitely a guy.
All right. I didn't catch a good enough look at the person in question.
But what's interesting is that he had no protection whatsoever. I mean, he didn't have a helmet. He didn't have a pressure suit on. He was just, in a T-shirt and a pair of stubbies. And I figured out why.
All right.
Whenever it comes to journalism and you're out there with a cameraman and you're taking footage of a nuclear attack or a Taliban attack, or the cameraman is expendable because you can grab the camera and still get the footage. The cameraman doesn't matter. So that's why he wasn't wearing a pressure suit.
Yeah. Maybe not.
Apologies to all camera people.
Yeah.
They do a great job, and sometimes they do dangerous work. And I'd say going up there under those circumstances is probably a high-risk venture. I imagine his life insurance would not have paid out.
Yeah, maybe not. Who knows?
Anyway,
as long as he had his seatbelt on, that's all right.
Yes, indeed. It's great footage, and if you want to see it, go to the BBC website because it's only a short piece of footage, about 55 seconds, but you'll get a real insight into what Virgin Galactic's doing, and that spaceship is... I want it. I want it in my garage, desperately.
If it turns up in your garage, you're going to be in big trouble, Andrew, I can tell you.
Yeah, I don't think my insurance premiums would stay very low for very long. Yeah. Anyway, it's a giant leap forward for Virgin Galactic. This is Space Nuts. Andrew Dunkley here with Fred Watson, of course.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
As has become our habit, we turn to the audience and answer a question. And this one came from David Putzia from Springfield, Oregon. And David asks, okay, so the universe is expanding. Not only is it expanding, but the expansion is getting faster and faster and faster. Sorry, David, you're wrong. It's getting faster and faster and faster and faster and faster and faster and faster. And not slowing down at all. So how then is our Milky Way galaxy going to get hit by the Andromeda galaxy? I think we're going to hit them, David. The expanding space of the universe should be moving them away from each other, right? Wrong? Is it just that the overall gravitational attraction between them is so great that it is overpowering this expansion? What a great question.
And David's basically given us the answer as well.
Well, thank you, David, and thank you, Fred. We'll see you all next week.
Yeah. It's exactly what it is. That there's a little bit more to it. The gravitational attraction's strong enough to overpower the expansion. The bottom line is that over distances like the 2.5 million light years that separates ourselves, our own Milky Way galaxy, from the Andromeda galaxy, and they're rather similar galaxies. The Andromeda one might be a little bit bigger than ours, but they're both pretty big.
Dog. We're bigger.
Yeah. Over the distance between them, which is, as I said, 2.5 million light years, the effect of the expanding universe is negligible. It's really only when you start looking at tens of millions, hundreds of millions, billions of light years that you see the effect of the expansion. For two things close together, if they're sitting in an expanding universe, the expansion is not going to do much in terms of separating them, particularly when you've got two massive objects like this, each with about 400 billion stars, and probably the same again, if not much more, in terms of the mass of other components like the dark matter and the other stuff.
So we might think it's a long way down the street to the chemist, but
that's right.
The distance between our galaxies is barely a glitch in terms of universal expansion.
That's right. So the two galaxies, because they're big, they've got strong gravitational attraction, they are falling towards one another, and the expansion of the universe really doesn't do anything to separate them. It's in some ways it's a bit like, I've always drawn the analogy, it's not a very good one actually, but if you imagine people in rowing boats on a river, you can row fast enough that you can overcome the flow of the river. So you might have a flow that's trying to pull you and your adjacent rowing boat apart, but if you pull hard enough, you'll get back together. And it's a bit like that with gravity and galaxies. There's a little bit more subtlety to this. The overall expansion the overall movement of objects due to the expansion of the universe, we say that they are participating in the Hubble flow. That's the name of it. We call it the Hubble flow. It's, as I say, it's like the flow of a river. That's the flow of space getting bigger. But in addition to being carried along by the Hubble flow, distant galaxies at very great distances also have their own velocities, which are velocities that are sort of superimposed on the Hubble flow, like the rowing motion that I just mentioned. They've got a name as well. It's a slightly peculiar name because they're called peculiar velocities. And that means is these are the velocities peculiar to the galaxy. So each galaxy has its own peculiar velocity, the velocity that's peculiar to it. But in addition to that, it's being carried along by the Hubble flow. And if you've got peculiar velocities like the Andromeda and the galaxy and the Milky Way galaxy, you can think of them as having a peculiar velocity towards each other, which is far more than the Hubble flow is.
Okay.
The impact is expected in about, well, let me put it more subtly. The first impact is expected in about 3.5 billion years. And we now know from really careful measurements that have been made by the Gaia spacecraft. This is a space probe that looks at the super accurate positions of stars in the sky, and they can actually see the sort of crosswise motion of the Andromeda galaxy with respect to ourselves, as well as the towards and away motion, which is the easy one to detect. And it turns out that we will make a glancing blow of the Andromeda galaxy in 3.5 billion years, and that will probably mean that the two galaxies, they'll sort of, they'll graze one another, and then they'll start spiraling around one another, probably come back and have another collision in another couple of billion years, and then 2 or 3 more after that. And eventually we'll settle down to something that doesn't probably have the beautiful spiral structure that both our galaxy and the Milky Way has. It'll be a much more uniform mass of stars. We're now talking 10, 20 billion years down the track. In fact, it'll probably be a bit boring. What the collision will do, though, is it'll stir up the gas in both our own and the Milky Way galaxy, and essentially trigger a whole lot of star formation. So, if there are any people watching our distant descendants, we'll see lots of supernovae. These are supermassive or massive stars that explode very dramatically. There'll be lots of that going on because star formation tends to generate supernovae as well as normal stars. So it'll be an exciting time for anybody who's still around.
And assuming the human race does survive, I imagine we will have found a way to visit the Andromeda galaxy before we even come close to colliding with it. I think that is the next progression. We're going to find ways of overcoming these distance issues to a certain degree, I think.
That's because you're a science fiction writer, Andrew, and,
Yes.
it's in your DNA to hope that we can overcome that.
And it was in David's DNA to consider that such a small distance between galaxies was infinitesimal. But in the scheme of things, David, you just weren't thinking big enough, really.
Well, but he's got the right answer in the end.
He's got the right answer in the question, yeah.
That's right.
So brilliantly done, David. Well done, and I hope that answered your question. It's it's just too small a distance to be a factor in the expansion of the universe. Quite simply, we could have said that and saved ourselves 7 minutes, but.
Well,
It does prompt another question in my mind. So Andromeda's going to be a hit, boom, boom, with us. Are there any other galaxies that are likely to become collision-worthy in the distant future?
Well, actually, in the nearer future, the two dwarf galaxies that are quite close to us, much closer than Andromeda, their distances are, the nearest one's about 160,000 light years away. These are what are called the Large and Small Magellanic Clouds. They're two patches of the fuzzy patches in our southern hemisphere sky. They're very beautiful, actually, when you see them in a dark sky. And they just look like broken off bits of the Milky Way. They are currently being eaten up by our own galaxy. So they are in the process of colliding. Now, that collision is a lot gentler because these are smaller objects, but it's still a collision nevertheless. And, the end product of that is going to be a lot more stars in what's called the halo of our galaxy. That's the region away from the disk, the sort of spherical region where a lot of older stars hang out.
But as you and I have discussed, even with the Andromeda collision, it's not going to be a catastrophic collision. It's just going to be so slow and so graceful. Everyone will just sort of get out of each other's way. It won't cause any problems, really.
It's very unlikely there'll be any direct collisions between stars. It'll just be, for 1 million years or so, there'll be all this excitement with a lot of star formation. And that could be dangerous because if you've got supernovae going off everywhere, they emit copious quantities of radiation of all kinds.
Yeah, you don't want to be near that.
You don't want to be near that.
It's like opening the microwave door before the beeps have stopped, so just keep that in mind.
That's right, yes.
And then reporting it in the news as some kind of alien technology or alien message.
They were called peritons at Parkes. They thought they picked up... In fact, there are these things called fast radio bursts, which we've talked about before, and the opening the microwave door actually mimicked exactly what one of them looked like.
It's one of the great stories in astronomy. Yeah.
Indeed, it is.
That and the colour of the universe, which was also
that was embarrassing. That
I love it. I think it's great.
I saw the guy who made that mistake actually last week at a conference.
Did you?
He's doing very well. He's
That's
a very
good.
eminent scientist in Australia now, but he did get the colour of the universe wrong for a while.
Yes. Well, these things happen. These things happen. And thank you again, David, for your question. We appreciate it. We love all your questions. We're going to try and get through them. We might have to dedicate yet another episode to questions only because they've piled up a bit.
Yeah, there's some good ones too.
Yeah, there's some rippers. Absolute rippers. I've lost them all, so that's why we haven't done it.
I've still got them, Andy.
Good. I've got to find a better cataloguing system. And thank you, Fred. It's always great fun.
And good fun to talk to you too, and we'll speak again next week.
We will indeed. Fred Watson, astronomer at large. He's a professor, and I'm not, but we will be back next week with another edition of Space Nuts.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Subscribe to the full podcast on iTunes and Stitcher or your favourite podcast distributor. This has been another quality podcast production from Bytes.com.